Hello students, welcome you all in Sudhi Jaswal Edu Maths. Today we are going to do the concept of probability. Here if we say the probability is like possibility or a measurement of possibility, it would not be wrong. So measurement of possibility in quantitative way is called probability. So how we form this? So it is like when we talk about probability, okay, here we probability. So we know that probability is actually number of favorable outcomes upon number of total outcomes. So when I talk about possibility, so if I toss a coin, then I have total number of events. I have head and tails. Okay, so this is our total number of events, we can say. Okay, this is the total number of event, and if you ask for head, that means you need head, so this will be your favorable events in this case. Okay, so you can say NE or NS or anyone. This is your favorable events, and total events NT. Okay, this is your favorable event NF. Okay, so when you find this, so what is the probability of taking head? So the probability will be, probability of coming head would be, you can write it like this: favorable number of favorable outcomes. You have only one outcome, release it, only one outcome in your favor, which is what? The head. Okay, out of these two, so you can write 1. So and total number of outcome, which is what? Head and tail, which is 2. Similarly, if you need what? Tail, if you demand for tail, so you have only one favorable case, which is what? Tails. Okay, so favorable number of outcomes would be tail, so you can say probability of coming tails in this case would be favorable outcome, number of favorable outcome upon, which is 1, out of what? Out of 2 cases, 2. Okay, so number of favorable outcome upon number of total outcome, you write in the probability. So let's take other example of throwing of 2 dice. Okay, throwing of 2 dice, you have total outcomes, you can say total outcomes would be head tail, tail head, head head, and tail tail. Okay, there are 4 outcomes in throwing of 2 coins. Okay, so if you need 2 head, okay, on the face, if you're tossing a coin, and if you demand for 2 head, so you would you have only one case here, which is in your favor, so you can write here favorable outcome. Outcome would be here, you will only write the cases. Okay, okay, favorable outcome is this is, so you can write that probability of your event. Okay, your event is what? 1 upon total number of outcomes, 1 2 3 4, 1 upon 4. All right, so and E denotes here that what do you need? You need what? 2 heads. Suppose if you want the probability of getting at least, okay, the case is, the event is you need at least 1 head. At least 1 head means you can take 1 head or 2 head, means head tail. Here you have head, in tail head you have head, and you can have also head. No, so what was that? At least 1 tail. Okay, at least 1 tail, so you can get 1 tail and 2 tails also. Okay, so head tail, in head tail you have tails, in tail head you have tails, in tail you have 2 tails. Okay, so in this case you don't have what? Tails in this case, so you not consider it. So you have favorable outcomes in which you are getting at least 1 tail as head tail, tail head, and tail. So when you find the probability of this event, it would be 3 upon 4. So number of favorable outcome 1, 2, 3 upon number of total outcome 1, 2, 3, 4. All right. And if you want to get the probability of at most one tail, okay. So at most one tail means you need 0 tail means no tail or one tail, okay. At most one tail means you need 0 tail means no tail. So your favorable outcomes is head head. In head head you don't have tail, and one tail means head tail and or tail head. So at most one tail you need 0 tail means in head head you are not getting any tails. In head tail you are getting one tail. In tail head you are getting one tail, but you cannot take the case of head head. So here you have also in at most one tail you are getting also a probability 3 upon 4. How? The number of at most number of what favorable outcome is 1, 2, 3 upon number of total outcome is 1, 2, 3, 4. All right. So these are the cases for I have learned about the at most, at least, and normal cases in throwing of two coins. Okay. So let's understand what if when we throw 3 coins. So the favorable outcome would be 2 raised to power n, total number of outcome 2 raised to power 3, it would be 8. Okay. So how would we consider? Like first you have to make what 8 boxes like this. Okay. You are going to write the favorable outcome here. So how would we find a favorable outcome? You have to write 4 heads like this, 4 heads and 4 tails, then 2 heads, 2 tails, 2 heads, 2 tails, 2 heads, 2 tails. Okay. Then you have to write head tail, head tail, head tail, head tails. Okay. These are the total outcomes. And if you want to find the in throwing of 3 coins, okay, this is the total outcome in throwing of, you can write throwing of 3 coins. Okay. So if you need to find at 3 places, like if you have thrown 3 coins here, and if you want to get head 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 on all faces, and if you want to find the probability of this, then you would be you have to choose that your favorable events out of this total outcome. Okay. From the total, not out of, from the total outcomes. So you need what head 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 on all the faces. So you have what, this one case only. So you write here favorable outcome like this, favorable outcome equal to only head head head. Okay. So now you can write the probability, that probability of getting 3 heads equal to favorable number of favorable outcome upon number of total outcome, which is number of favorable outcome is 1, and out of total upon number of total outcomes, which is 8. All right. So now let's move on. How would we find the probability of dice? Okay. If we are throwing a dice, so we have 6 possible cases, 1, 2, 3, 4, 5, 6. Okay. So possible outcomes, you can say, possible or total outcomes, you can say, total outcomes, if you want to get the find the probability of odd numbers from the probability of getting odd numbers in throwing one die. So probability of odd numbers, so you can write here favorable outcomes, it would be odd number, so 1, 3 and 5. So you have all 3 cases in your favor. So probable of coming what? Odd number, okay, equal to, how many cases are there? How many favorable outcomes? 1, 2, 3. 3 upon total number of outcomes 1, 2, 3, 4, 5, 6. Okay, 3 upon 6, it would be 1 upon 2. So let's talk about the probability of throwing, sorry, events of throwing two dice. Okay, so total outcomes would be 36. Outcomes would be 36. How? 6 raised to power 2. So it is 1 1 1 2 1 3 1 4 1 5 1 6. Okay, 2 1 2 2 2 3. Similarly 2 6 3 1 3 2. Similarly 3 6 up to, okay, here 4 1 4 5 1, and you can write here 6 1 6 2 6 6. Okay, so if you count all these, you'd get what? 36 cases. So you can write here 4 1 5 1 4 2 5 2. You can write here total 2 4 2 5 3 3 3 4 3 5 4 3 4 4 4 5 5 3 5 4 5 5 4 6 5 6 6 3 6 4 6 5. Okay, so these are 36 cases, and if you want to find the probability of coming same number on the faces, okay, say on the top, same number on the same numbers on the throwing of two dice. Okay, same number means you're getting on the both faces. Like if you're throwing a die on both faces, you need what? Suppose same number like 1 1 or 2 2 or 3 3, 2 2 or 3 3 or 4 4 or 5 5 or 6 6. So how many cases you have? 1 1 2 2 3 3 4 4 5 5 and 6 6. So you have to write favorable events like this. You need what? Same number on the faces. So 1 1 on throwing of two dice. Okay, so 2 2 2 3 3 4 4 5 5 and 6 6. All right, so these are the favorable events, and your total events is this. So how would you find the probability? Number of favorable outcome, which is 1 2 3 4 5 6, upon number of total outcomes, which is 36. 6 upon 36, when you cancel this, 6 upon 36, 6 1 is 6, 6 36, your answer would be, the probability would be 1 upon 6. Okay, and if you want to probability of getting some 7 in the throw of what? In the throw of two dice. Okay, if you want to get the sum on the dice, or some of the numbers on the dice, 7, like, so your cases would be like, if you're throwing a two dice here, two dice, and you need some 7, so you can get here 5, either 5 or 2 or 5 here, you would get 7, or you can take 4 3 or 3 4, you would get 7. Okay, you would, if you place 6 1 or 1 6, you would get 7. So you can write here favorable outcome, what? 5 2 2 5 6 1 1 6 and 4 3 and 3 4. Any other cases? 5 2 7 6 1 7 4 3 7. Any other cases? think about this. Okay, 4 3 1 5 2 2 5 6 1 1 6 4 3. What about 2? We haven't taken 2 plus 5. Yes, we have taken this 1. We have taken this 5. We have taken this 4. Oh, okay. So these are the cases. So how would you find the probability? Number of favorable outcome upon number of total outcomes. This is 1, 2, 3, 4. Like you write, probability of the event would be how many cases? 1, 2, 3, 4, 5, 6 upon total cases is 36. So 6 upon 36, 1 by 6 is the probability. Okay, so we can do this question like this. So let's talk about the problem based on cards. Okay, as you know, in playing cards you have 36 cards. Okay, so in 36 cards we have spade, diamond, spade, club and heart. Yeah, so I'm going to make, okay, this is the heart, diamond. Okay, so heart and diamond are in red color, and club, okay, I think it is like this, and spade is like this maybe. Okay, so these two cards are, so you can write here heart, club and spade, and these two cards are heart and diamond. So we have in all the cards we have what? So total number of cards we have 52 cards. Okay, we know this, but in heart, which is in red color, we have 3 face cards. Like the face cards are king, okay, king, queen, jack. Okay, these are the face cards. Okay, ace. Okay, it is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so we can write here 8, 9 and 10. Similarly, in diamond we have also king, queen, okay, jack, ace, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, similarly here we have also king, queen. In club we jack, ace, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Similarly, king, queen, jack, ace, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we have 13 cards of each. Heart contain 3 face card and 10 non-face card. Okay, diamonds in similar way, diamond, club and spade contain 13 cards. So when you calculate all the cards, it would be 52. So if you want to get the answer, that if find the probability of, if you have a card, and if you are going to well shuffle it, and if you want to pick one card from your well shuffled card, so find the probability of getting a red card. Okay, find the probability of getting red card. So you have to consider how many red cards are there in your playing card. So you have to 13 heart and 13 diamond, these are red cards. So 13 plus 13, 26, which is in your favor find the red card, okay, coming red card equal to the favorable case is what, 26 upon your total card is what, 52. So you can find the answer 1 by 2. When you cut it, you'll get 1 by 2. As you know, the probability, in the probability you get the answer between 0 and 1, and probability of sure event is 1, and probability of impossible event is 0. Okay, so I'm going to give the case of impossible event here. If you have a well shuffled card and you are set to remove all face cards here, okay, you have to remove all face cards, and then you are given to a card and you are set to well shuffle it, okay. And if someone asks you to find the probability of getting face card, okay, find the probability of face card, so you would consider that, or think like this, the card which you have, the examiner or someone who provided you the playing card, and he had a condition that you have to remove all the cards. So you have removed your cards, all the face cards, so you would not have any face card this time. So if someone asks you again to find what the probability of face cards, so you would say that there is not any case in our favor, so you could write the favorable event as 0, number of favorable event as 0 upon number of total events, which is 52. Okay, no, sorry, not 52, because it was the condition that you need to remove all the face cards previously. That's so you have removed how many cards? 1, 2, 3, 3, 4 are 12. You have 12 face cards, so you have already removed it. So in this case, you would not have the face card. So how many cards are there? So you have 40 cards. So you would consider your total outcomes from the 40 cards. So it would be 0. Okay. If someone asks, this is the impossible event. Okay. If someone asks, so have you understood the question? You have given a card and you are told to remove what? Remove all the face cards first. So you have removed it. Now your card have these numbers, okay, and you are set to well shuffle it. And if you well shuffled it, after shuffling the card, you are told to pick one card from it. And if someone asks you to get the probability of coming ace, so you would have ace 1, 2, 3, 4. You have 4 ace, okay. You have 4 ace, and total number of outcomes, it is not 52, because it was the condition that you need to what, remove your face card previously. So you would consider the rest of the card. You would consider your total outcomes on the rest of the card, which is what, which is 40. When you consider 4 1 4, 4 10 40. So we'll talk about this. So there are many questions. So I think we have done all three coins. Okay, now I have some questions related to this. Okay, some MCQs if you want to write. In a throw of a pair of dice, what is the probability of getting a duplet? In a throw of pair of a dice, find the probability of duplet. So in a throw of pair of dice, so you have total outcomes, number of total outcomes. What I have told you, total outcome equal to 36. Okay, you can rewind your video and see what was the total number of outcomes, and you need to find what is the probability of getting a duplet. Okay, so number of favorable outcome. So how would you find this? So in order to find the number of favorable outcome, you have to know about what is your outcome. What is your favorable outcome? So you need to find duplet. Okay, DOUBLET. Okay, duplet. Okay, so it is 1 1 1 2 sorry 2 2 3 3 4 4 5 5 and 6 6. These are 6 doublet in the throwing of 2 dice. Okay, so your number of favorable outcome is 6. 1 2 3 4 5 6, and you need to find the probability of these. So what would you write? Probability of, and probability would be number of favorable outcome upon number of total outcome. It would be 1 upon 6. It is a multiple choice question, so your answer is 1 upon 6. The second question is the probability of getting a bad egg from a lot of 400 eggs. It is given there. You can write this question. The probability of getting a bad egg from a lot of 400 eggs is 0.035. Probability of coming what? Getting a bad egg. Bad eggs. Okay. Eggs from the lot of 400. From the lot of, that means suppose you have 400 eggs in a lot. Okay. And if you want to get what? A bad egg. So bad eggs and good eggs. Okay, there are two conditions, two possibilities. Good eggs. So it is given that the probability of getting a bad eggs from a lot of 400 eggs is 0.035. Okay, the number of bad eggs in the lot is, so number of bad eggs you need to find. So suppose the number of bad eggs be x. Okay, suppose it is x. So how would you find the probability? Favorable number of outcomes upon total outcomes. The total outcomes is say 400. The favorable outcome is x. So x upon what? 400 equal to 0.035. It is given. So what would you do? X equal to 0.035 into 400. So when you multiply this, you'll get here 4 5 20, 0 2, 4 3 are 12, 2 14. Okay, and 0 0, and how many decimal you have to place? 1 2 3. So okay, so x would be 14. Is it the answer or not? 14x. Yeah, all right, it is the answer. I hope you have understood. We have, I think, 16 questions maybe. The probability of guessing the correct answer to a certain question is p by 12. Write the question. The probability of guessing the correct answer to certain question is p by 12. Probability of guessing. Okay, probability of guessing answer equal to p by 12. If the probability of not guessing the correct answer to same question is 3 by 4. Probability of not guessing of same question. Okay, not guessing same question is 3 by 4. The value of p. Okay, as you know, probability of guessing the answer and probability of not guessing the answer is 1. Do you know this? Okay, as you know, sum of all probability is 1. Okay, sum of all probabilities, all the possible cases is 1. Probability of happening and sum of the probability of happening and probability of non happening is 1. What? Probability of happening, or you can say plus probability of non happening, okay, is equal to 1. Or you can also write probability of happening an event, or probability of non or not happening that event is 1. Okay, always 1. So here we are going to apply here probability of guessing an answer is p by 12. Okay, so probability of happening is p by 12. Okay, and probability of non happening an event is 3 by 4, and you know the sum is 1. So you can what, p by 12 plus 3 by 4, you can apply here p by 12 plus 3 by 4 is equal to 1. Okay, p by 12 equal to 1 minus 3 by 4. It would be what? 4 by 4 minus 3 by 4, it is 1 by 4, and your answer would be p equal to, of course, 3. You need to cross multiply it. Is it the answer? Yes, it is. Okay. Next question is, in the throw of 2 dice, the probability of getting a sum of 10. Oh, in a throw of 2 dice, okay, in the throw of 2 dice, you know that number of total outcomes. Total outcomes, what it is? 36. And you need to what? In a throw of 2 dice, the probability of getting a sum of 10. Okay, so you need to write favorable events first. Favorable events, try to guess what? You need to get sum 10. So it would be 5, 5, 10. The easy one, what? 6 plus 4, 10. 4 plus 6, 10. And what more? 5 plus 5, 6 plus 4. Okay, 5 plus 5, 10. What next? Okay, 5, 4, 3. No. Only 3 possible cases are there, I think. Yeah. So now you have to, how would you find the probability? Probability of that event is number of favorable outcome, which is 3, upon number of total outcome, which is what? 36. 3 1 3. Is it the answer? I have to check. Yes, it is 1 by 12. Yes. I hope you have understood. These are multiple choice question. Now, the probability that a non-leap year selected at random will have 53 Tuesdays. Non-leap year. Okay. So I am going to write again. Read this question again. The probability that a non-leap year selected at random will have 53 Tuesdays. So when we talk about non-leap year, in non-leap year you have 365 days. Okay. And when you divide with the 7, you will find the number of weeks. So it would be 7 5s are 35, 1, okay, 7 2s are 14. So here you have what? 1 extra day, because you are getting remainder, okay, as 1. So you can say that you have 1 extra day. Now, so you have 52 weeks. So you have what? Get the information by dividing your number of days with 7. You got 52 weeks, but 1 extra day. So in 52 weeks means you have 52 Sunday, you have 52 Monday, Tuesday, Wednesday, okay, Thursday, Sunday, Monday, okay, Tuesday, WEDNESDAY, Wednesday, THURSDAY, Thursday, Friday, Saturday. Okay, so you have 7 possible cases. So you have you know this, you have 52 Sunday, 52 Monday, 52 Wednesday, Tuesday, Thursday, Friday, all 52. Okay, and you need to, the question is the probability that a non-leap year selected at random will have 53 Tuesdays. 53 Tuesdays, you are talking about 53 Tuesdays. So we have not any possibility in this case, since we have what? Equal number of possibilities here. So these are equally likely, we can say. You can get, we are going to focus on only what? The Tuesday. Since we have 52 Tuesdays here, 52 Tuesdays here, so we need 53rd Tuesdays. So we have the 1 extra day. For 1 extra day we have 7 possible cases. We can get Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so we have 7 possible cases for 1 extra days. So since we need 53 Tuesdays, so we need this one day is only our favorable case out of 7 days. Okay, so your probability of the event would be what you need, since you have 52 Tuesdays already you have, and you need to get only one more Tuesday because it is your favorable case out of what 7 total case. 1 2 3 4 5 6 7. All right, so 1 by 7 is the answer. Want to check? Yes, it is. Now the question is, if the probability of happening an event is p, then probability of not happening is 1 minus p. Probability of happening an event is p. Okay, probability of non happening an event question mark. As you know, probability of happening plus probability of non happening is 1. You know this. So what is the probability of non happening? When you transpose is happening, you'd get probability of E. What is this? 1 minus. What is the probability of happening? It is P. So you can say that probability of happening is, if probability of happening is P, what is the probability of non happening? It is 1 minus P. Very easy question. The probability of drawing a green colored ball from a bag containing 6 red and 5 black. 6 red and 5 black. You need to check, look for the green colored ball. Man, there is not any green color, so it would be, probability would be your favorable event. What is the favorable event? 0. Okay, out of total event is what? 11. 0 upon 11, it is 0. Okay, impossible event. Next question is, if the probability of winning game is 0.0995, then probability of losing game, same question, subtract it by 1. Okay, you would get the answer. If the probability of winning a game is 0.995, what the probability of losing a game is 1 minus 0.995. You will get the answer. All right. So how would you subtract it? 1.000, 0.995, like this. Subtract it like this. 10 minus 5, it is 5. Okay. 10, 9, 9, and you 0. So 9 minus 9 is 0. 9 minus 9 is 0. 0.005 is the answer. Okay. Now, if a die is thrown once, the probability of getting a number less than 3 and greater than 3 and greater than 2. Okay, if the die is thrown once, if the probability of getting a number less than 3. Okay, so if you have thrown a dice, so you have 6 total outcomes. Okay, 6 outcomes. And the probability of, what is the probability here? That the probability of getting a number less than 3 and greater than 2. Less than 3 and greater than 2. Okay, 3, less than 3 and greater than 2. Do you have any number less than 3 and greater than 2? I don't think so. Is there any number greater than 2 and less than 3? Is there any number? No. So you don't have any favorable outcome. So what you can say, this is again the question of impossible event, where you have no any favorable outcome. 0 upon total is 6. Okay, so it is favorable outcome, favorable. Okay, f is the favorable outcome here, and you don't have any number less than 3 greater than 2. That's why the answer is 0. Now let's move to the another question. Alright, the probability of getting a number between 1 and 100 which is divisible by 7. Okay, probability of getting a number between 1 and 100 which is divisible by 7. Which is divisible by 7. Alright, 1 and 100 divisible by 7. So 7 is the first number with double 14. Okay, 7, 14, 21, 28, 35. Okay, the multiple of 7. Okay, now you have to add 7. 77. 7 plus 7, now it is 84. Okay, now again you have to add 7. 7 plus 4, 91. Okay, again you add 7, you would get 98. Now these are the total outcomes. Okay, so these are the multiple of 7, you can say, between 1 and 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 numbers. So what do you have to get? The what? It is the not total outcome. It is a favorable outcomes. Favorable. Okay. Outcomes. Because you need to get this. And what is the total? Total number is 1, 2, 3, 4. I think yes. 100 number. Okay. Total outcomes. So probability of event would be what? 14 upon 100. I think 14. 1, 2, 3, 4. Yeah. So 2 7 ja 14 and 7 upon 50 is the answer. I think I have to check this. Yes. If okay. Next question is, if two coins are tossed simultaneously, then probability of getting at least one head. My God, two coins are tossed head head, head tail, tail head, tail tail. So you need to get your favorable outcomes. At least one head. At least one head means you can get one head or two heads. Like head head, head tail, tail head. At least one. So we will not consider tail tail here. Okay, it is your total outcome. Now you need to find what probability of this event would be number of favorable outcome, which is 3 upon number of total outcome. 1, 2, 3, 4. 3 upon 4. All right. So need to check it. Two dice are thrown simultaneously. Probability of getting a prime number on both dice. Oh, this is the interesting one. You need to write all and prime number on the both dice. Okay, let's check it. Two dice are thrown simultaneously. So we have 1 1 1 2 1 3 1 4 1 5 1 6. So do we have any prime number on both the faces? So 2 3, no prime number. 2 1 2 2 2 3. Yes, we have. This is okay. Both the faces prime number. 2 4 2 5 2 6. No. So 3 1 3 2. This one is also okay. 3 3 3 4 3 5. Yes, this one is also okay. 3 6 4 1 4 2. So we will not consider because 4 is not the prime number. Okay. 5 1. Yes, 5 1. This one. Okay. 5 2. Yes, this is also. Oh, so I'm sorry. 1 is not a prime number. I'm sorry. 5 1 5 2. Yes, this case. 5 3. Yes, this one. 5 4 5 5. So can I consider Okay, can I consider what 2 dice are thrown diamond? Find the probability of getting a prime number on both dice. Find a prime number on both dice. Okay, so you would consider also 2 2 case 2 2, yes, and I'm going to consider here 3 3 also. I'm going to consider here 5 5 also, because these are also prime numbers. 5 6 6 1. I will not take the case of 6 1 because 6 is not a prime number. So I have taken the cases of 1 is not prime, cut it. So we have only option 2 1. Check it out. 2 1, is it a no prime? 1 is not prime number. 2 2, yes. 2 3, 2 5. This one is also okay. 2 5, yeah, the prime number here. 3 1, 3 2, 3 3, 3 3, 3 4, 3 5, 3 6, 5 1, 5 2, 5 3, 5 4, 5 6. So we how many cases? 1 2 3, 1 2 3, 1 2 3. So we have 9 favorable cases out of total 36. So it would be 9 4 the 36, 1 by 4. I hope you have understood. You have to check it out. 1 by 4, yes, the answer is correct, both this. Okay, search with you what you have not on the internet. Okay, let's move to the next question here. If the letter of English alphabet is chosen at random, then probability that a letter is a consonant. Okay, so if a letter is of English alphabet is chosen at random, then find the probability that the letter is a consonant. So how many letters are there in the English alphabet? 26. Okay, in which that 5 vowels are there. A E I O U, A E I O U. Okay, so these are the events. Okay, 5 events. Vowels. Okay, these are the vowels, and consonants. There are 21 consonants. So we are going to write the number only. So what do you have to find? If the letters of English alphabet is chosen at random, then probability that that the letter is consonant. So you have how many cases you have? 21 upon total. Total is 26. Yeah, this is the answer of your event. Okay. The probability of getting a prime number in a single throw of die. Prime number in single throw of die. 1 2 3 4 5 6. Getting a prime number, your favorable event is 2. Okay, 2 3 and 5. 2 3 and 5. So the probability of that event is number of favorable outcome, which is 3 1 2 3, upon number of total outcomes 1 2 3 4 5 6. It is 1 by 2. All right. Next question here. The last one. Which one of the following cannot be the probability of an event? Which one of the following cannot be a probability of event? And the probabilities are 1.1, 0.1, 0.9, 5%. So 1.1, 0.1, 0.9, and the last is 5%. So do you want to check it out? 1.1. Oh, this cannot be. I think the probability is defined only in between 0 and 1. So it is more than 1. Here it is not possible. Yes. So yes, it is possible. It is 5%. 5%, 1 upon 100. Okay. It is 0.05. This is also possible. It comes in between 0 and 1. So all numbers except 1.1. So this 1.1 is not. That does not come under probability. I hope you have understood the section of probability. We will do different question in the next class. Thank you very much for watching this video. Thank you.